All right, hey everybody, it's Miss Summers. Today is September 9th, 2020. It's another lovely asynchronous day. So yesterday we talked about seasons. We're going to continue talking about how Earth moves through space today and what those motions cause here on Earth. Okay, so we'll be looking at 4 specific types of motions, and then we'll be throwing a couple new terms your way. So lots of vocabulary today. Something for y'all to study this week. All right, so the first thing that I want to talk about is this. Does the Earth revolve around the sun? Now, I know at the beginning of the unit we talked about how the solar system is heliocentric, how things go around the sun's kind of in the middle of everything, and stuff goes around it. But I'm going to tell you, the Earth does not revolve strictly around that sun, and the sun doesn't stay still. Both those things are moving, all right? And they are moving around this thing called a barycenter. All right, so the Earth and the sun orbit a barycenter that lies between them. The sun is very large, so the barycenter is very close to the sun. You can think of barycenter like the fulcrum of a seesaw. A fulcrum is the thing that the seesaw balances on. Imagine if you had a really, really large child, like a really big kid, and a really, really tiny kid. All right, and they wanted to play on the seesaw or balance themselves out on the seesaw. The really big kid would have to sit close to the middle, close to this fulcrum, in order to balance out with this little small kid over here. And that's kind of what happens. So what I want to show you, I want to give you a demonstration of that. So I'm going to flip over here to Visualizer, and you can see my pretty face. Hello, everybody. So I have this ruler here. I have a very large mass on one end and a very small one on the other. Okay, so this would be the Earth. This would be the sun. If the barycenter were here in the middle, obviously that's not balanced because the sun's a lot bigger. So the barycenter is always going to move, or is always going to be closer to the bigger object. So you see how that balances? And now as they orbit, so the large mass, the sun, is moving ever so slightly, while this little mass goes around this point here, the barycenter. Okay? So there is a barycenter between all planets and the sun, and all planets and their stars. So the sun kind of moves just ever so slightly. That's how we know there's planets around it. All right? I'm going to jump back to my presentation. Okay? So barycenter. Think of it like a seesaw. Barycenter is always close to the bigger thing. All right? Now let's look at we're going to skip the video because I showed you that demonstration. Now we're going to look at our main motions of Earth. There's 2 main ones. We already talked about one yesterday. All right? The first motion is called rotation. When something rotates, it spins. Rotation is the spinning of the Earth on its axis, and it takes about 24 hours. There's 2 ways you can determine rotation, but they're both pretty close to 24. All right? Rotation, write this down. Rotation causes day and night. All right? So I'm going to demonstrate. I'm going to demonstrate for you. I'm going to jump back over here to my visualizer so you can see me again. Hello. All right, so here's the Earth. Remember yesterday we said the Earth is tilted at 23.5 degrees, thereabouts, plus or minus. As it rotates, it just does that. It's just a spinning. Okay, now, let's take this flash. Actually, let me move you over here for a moment. So I have this lamp that is so conveniently placed here. Aha! All right. This side that is facing the sun, so this side, you see how the sun's reflecting off of it, that side is experiencing daylight. These folks over here that's in the shadow, this is nighttime. So as it rotates, one side will enter into daylight, the other side will enter nighttime. All right? And that's why we have time zones, essentially. All right? That's why when you call your friend or your grandma that lives overseas or whatever, they'll be like, what are you doing? It's 3 in the morning. And you'll be like, no, it's not. It is over there. All right. Wonderful. Let's jump back to the presentation. So rotation is spinning. Rotation also causes this really snazzy side effect. Remember with nebular theory, how we said when things rotate, they start to flatten out like a ball of pizza dough. It kind of gets flatter as it spins faster and faster. The Earth, it kind of does the same thing. As it rotates, the ends of the Earth, so right here, they kind of get squeezed, and it starts to widen out here in the middle. So the Earth is not like a perfect round sphere like a basketball or a soccer ball. It's a little wider here in the middle, this way, than it is this way. The shape of our planet is called an oblate spheroid. It just means it's a slightly squished sphere. That's all I need you to know. Okie dokie? All right, so rotation causes day and night, and it causes our planet to be an oblate spheroid. All right, our next motion is revolution. And we talked about this yesterday with seasons. Revolution is the motion of Earth along a path around a point in space. So in this case, it's the Barycenter, which is basically right next to the sun. A revolution takes 365.25 or 1/4 days. So that's why every 4 years, we add a new day to the calendar. In February, we have a leap year like we did this year. All right, in 4 more years, these extra quarter days add up. That's why we can do that. Okay, so let me demonstrate that for you. I'm going to turn off this sun, and I'm going to pretend I am the sun now. So I'm going to take my little Earth. I'm going to come back to Visualizer. You're going to see me. All right, so I have my Earth. It's spinning. Now, I'm going to be the sun. All right, so I'm going to take my flashlight. Ooh, I'm the sun. Look at me. Okay, so here's revolution. Going around the sun. Going around that Barycenter. Note that my head is kind of rotating, or revolving too, around this flashlight. This flashlight is essentially the Barycenter. All right. Now, what does that cost? Again, we talked about this yesterday. This should be a review. Because the Earth is tilted, it's not standing straight up and down in space. It's tilted. Different hemispheres point towards or away from the sun at different points in the revolution. The tilt doesn't change, but as revolution happens, one side will be tilted one way, the other side will be tilted the other. So here, in this part, this is in June, the northern hemisphere is pointed towards the sun. That means it's summer here. But on the other side, in the southern hemisphere, they're pointed away, so they're experiencing winter. All right, as revolution happens, 6 months later, we're halfway through the revolution. Well, now the southern hemisphere is pointed towards the sun, and we're tilted away. Please note that the tilt didn't change through the revolution. We just changed where we were in our orbit. We changed where we were in revolution. All right, so rotation causes day and night, and causes our Earth to be an oblate spheroid. Revolution is us going around the Barycenter that we share with the sun. It causes seasons, and it lasts a year. Our next motions are the minor motions. So these are motions that you're probably not familiar with. The first one is precession. Precession is extremely slow. All right. Is a continual change in the direction of the Earth's axis that the Earth's axis points. Basically what it's saying, it changes which way we're facing in space. It does not change the tilt, it just changes which way we're facing. So this motion takes approximately 26,000 years. And where we are right now in space, our planet is facing this way. This is our tilt. Right now, Polaris is our North Star. That is how you find true north. You look for Polaris, and you can figure out where you are on Earth. In about 13,000 years, when we're halfway through the cycle, we're going to be pointing the opposite way. We're still going to be tilted at 23.5 degrees, but now we're going to be facing Vega. So it's kind of like a top. So I'm going to jump back to myself. It's just like being in class. Isn't this fun? Of course it is. And I'm going to jump back to me. So again, here's my Earth. Here's rotation. Here's revolution. Precession is this. Whee! Whee! I'm basically drawing a circle with the Earth's axis. Nope, my tilt is not changing. I'm not changing. It doesn't get more straight up and down or more on its side. It's staying tilted. It's just changing which way it's facing. This is precession. Super slow. Super fun times. All right, precession. All right, just changes where we are in space or which way we're facing. All right, our next minor motion is nutation. The word you can remember with nutation is wobble. Wobble. A nutation is a wobbling effect. All right. It causes, this happens during precession. And with nutation, the tilt of the Earth does change ever so slightly. So sometimes it will wobble and it will be more straight up and down. And sometimes it will wobble and it will be more on its side, it being the Earth. Because nutation impacts the tilt, it does have mild impact on seasons. So let me show you. So here I am again. Hello, everybody. So here's precession. All right. During nutation, the Earth does this number. So it's a wobble. So remember, I'll turn the sun on again. Over here. So remember, if there were no tilt, there would be no seasons. So when nutation happens and the Earth stands up a little more straight, the angle gets less, the seasons aren't as extreme. You have less differences, less variation. But if it tilts a little more, the angle increases, the seasons get a little more extreme. Now, again, we're not going from like here to here to here. It's a very slight motion, a slight wobble. So you have a slight impact, okay? More angle, more seasonal extremes. Less angle, less extremes, all right? So that's our four motions. Rotation. Rotation is the spinning that causes day and night. Revolution, going around, which causes the seasons because the Earth is tilted. Precession, which is this very slow drawing a circle motion in space, just changes which way we're facing. That's all that changes. And then nutation is the wobble. The wobble. So sometimes we're more up, sometimes we're more on our side. That has a tiny effect on seasons. All right, so those are our four main motions. And then, of course, along with Barycenter, you learned what that is. So what I want y'all to do with this information, I'm going to go back here. I want you to go to Canvas. All right, just like we did yesterday with our little like takeaway discussion, I want you to answer today's takeaway discussion. What did you learn? Okay, what was new to you? What did you already know? And then what questions do you still have? All right. Tomorrow you will have another asynchronous day. You will look at the sun, and then I will see you all on Friday, and we're going to talk about the moon. If you have any questions that you cannot wait until then, feel free to email me or message me in Canvas, and I'll get back to you.